Hello everyone. I'm Kamalesh from Department of Computer Science and Engineering from South Engineering College. Today, I'm gonna present about my mini project, the cryptic algorithm detector, which a machine learning based system where we will be identifying the cryptic algorithms used in the given text. So, what is this cryptic algorithm? This cryptic in today's digital world, cybersecurity is for cybersecurity and digital forensics are play a crucial role. During investigation, professionals often come across unknown strings of data. For example, is this data encrypted or is this data hashed? Or this is an normal encoded or plain text. Manually identifying this cryptographic algorithm is requires a lot of expert knowledge and takes a lot of time. And this manual identification of cryptography even also takes lots of errors and we will not be able to identify the cryptographic algorithm correctly. So what is my idea is I have developed an machine learning model so that it will be useful for identifying the cryptographic algorithm. So what is the problem statement? The main problem addressed in this project is identify the difficulty in accurately and quickly identifying cryptographic algorithm used to an unknown piece of text. That is, identification is done manually by most of the companies and it depends on experience, like how well the person is knowledgeable about the cryptographic methods and the algorithms, and the method of manually identifying cryptographic algorithm is slow and unreliable. So this machine learning models will analyze the model algorithms and it will judge the word by the patterns present in the word and it will say the algorithm type. What is the scope of this project? The primary goal of this project is to for develop an intelligent and automated system for rapid and accurate identification of cryptic algorithms. The main objective of the system are algorithm classification, that is, identifying and classifying the algorithm based on the input given by the user. Like we can detect modern encryption algorithm like AES and hashing algorithms like SHA-256 and plain text and CSS cipher, since these algorithms are mainly run in the today's network and the applications. So this machine learning model reduces manual effort, act as a first pass analysis tool, and for educational purposes for students, it will be useful for them to identify different types of encryption and they can differentiate between different algorithms by identifying the changes in the both encryption and hashed methods. What is the methodology of this? So our system is designed as a full stack application, that is a web development pitch. Here the front end, here it had mainly three parts: the front end, back end, and the model. The front end is built using CSS, JavaScript, and HTML, where the user can paste the text and view the algorithm which the text has. The user can paste the algorithm and instantly get the predicted algorithm. This front end communicates with the backend using fast API, sorry, REST API. Next is the backend or the web server. This is developed using Python Flask framework. The main responsibilities of this backend is receive user input from the front end, send data to the ML model, and return the prediction result. That is, the backend acts as a mediator between the front end and the machine learning model. Why we have used Flask? Flask is a lightweight, fast, and ideal for the application where we should get instant result by giving the input. Next is the machine learning model. The machine learning model here I have used is random forest classifier, and I have trained the model based on synthetic cryptographic data. So the extractor feature include entropy, that is how much the word is accurate, and the character frequency, number of character inputs, because many algorithms have different character standard length, and these patterns, like one every algorithm will have a different type of pattern in them. Next is, this is the architectural diagram of our model, where we'll be creating the data set, we'll be pre-processing it, we'll be feature scaling, splitting the data, and we'll be training the model based on the data which is generated by the model itself, and we'll be saving it, and we'll be giving the real-time prediction by the algorithm. The user will be using the web interface. This is the UML diagrams. So this is random forest machine learning model. It will be training the data sets, splitting the data sets, weights the model, validate the input, and detects the algorithm. The data set is pre-processed by the random forest, and the user will be giving the input, and they will be receiving the output. Next is class diagram. This is the for class diagram for our model. Class diagram will be having two, admin and user. Admin will be taking care of all the details of the backend and front end. The user will be interacting only with the front end. This is a sequence diagram where user will be giving the ciphertext, and the model will be extracting the feature, validate the feature, and model and the random forest weights the model. Then it will be classifying the algorithm, and the algorithm will be sent to the front end. So what all algorithms I have used? First is the random forest algorithm classifier. This is the primary algorithm used in this model. So this is the basic software requirements and hardware requirements for our project. That is a basic standard computer and a Windows 10 and Linux. So OpenCV, PyTorch are the libraries which I have used. This is the code segment. This is for app.py. This is the backend code, and this is also for backend code. This is the model code which I have used. This is the output for our algorithm. These are the test cases which has been used. So our algorithm mainly classifies the word input given by the user into different cryptic algorithm types. Future work, like we can be using this as more advanced automated systems by directly getting the input from the network and detecting it. We can also, for the development of quantum computers, we can use this model to identify the word which has been encrypted. For references, I have used Al-Charfas and Al-Arch automated identification of cryptographic algorithms, and random forest classification by Mr. Wong, Mr. Zhu, and Mr. Wong. You can post your questions. So now let's take a look at the model. So this is the code which I have used. This is for backend, where we'll be using this is the intermediate, where it will be connecting the front end and the back end, I mean model. And this is the train model, so we'll be having crypto model and feature info. These contain the train data, and this is the model Python machine learning model for detecting it. Here we can check it is base 64, hit set X, and Does it contain plain English words? We'll be extracting the feature. For this function is for AES algorithm. This is for RSA. This is for SHA, and this is for Caesar cipher. This is the code which we'll be using. We'll be evaluating the model in this. We'll be training and we'll be evaluating it. This English word text contains list of English word which will be used. This is our HTML page. We have make it. I have made it simpler for easy access and understandable one. This is a JavaScript, and this is my CSS for enhancing my web page. So this is the model. This is an example of SHA-256. So I have got SHA-256. Now I'll paste some other examples. This is a plain text. Now I'm pasting it. We have got the result as plain text, and we have got the entropy and feature calculation of the machine learning model. This is a Caesar cipher. This is same as hello world. It is been encrypted. We have got the result as Caesar cipher. Next is AES. We have got the result as AES. Most of the AES algorithm will be having last two equal to's at the last for identifying them, and this is SHA-256. So this we have identified this as SHA-256. That's all it's about my project. I hope you guys have it understood it well. Thank you.